Goedenamiddag iedereen. Waanzinnig tof om hier op het podium van SAS Forum, mainstage te staan. Ik ben Andrew Pease. Ik leid de analytics ploeg in de Global Technology Practice. Ik ben die Amerikaan die Vlaams spreekt. Ik heb Nederlands geleerd, puur uit zelfverdediging. Mijn kinderen spreken het, dus ik moest het ook leren natuurlijk. Maar ik voel me op mijn gemak vandaag. Ik voel me niet dat ik me moet verdedigen. Dus ik ga gewoon overschakelen naar het Engels, als jullie dat goed vinden. So, we're going to talk a little bit about machine learning and what that means for us. In the machine learning world, I'm going to give you some best practices, and we're going to talk about one key concept, augmentation, which I think is important for everybody in this room and everybody on the planet. Before I do that, I want to give you guys a little bit of energy. I want to do a little exercise in pattern recognition. And you're all going to do that with me, okay? So what's this? Come on. All right, that's a simple pattern, right? We know what we're doing with that simple pattern. But not all patterns are quite that easy. Remember that pattern, we might need it later. A little predictive modeling for that. But not all patterns are so simple. We talk about the driverless car and what Uber is saying about the driverless car. This is them talking about all the interesting technologies around driverless car and all the data that they're collecting, and that's all very interesting. But what's missing from this picture? There is nothing about learning. There is nothing about machine learning in this picture. And so what that tells me is they're starting to take it as a given commodity. That, oh yeah, the machines learn. Of course, don't worry about it. The machines learn. I think that's a little bit wrong. And I'm going to tell you why. Driverless car, American, living in Europe, living in Belgium, driving a lot in the Netherlands. Voorrang van rechts. I'm sorry, if you're not growing up with that concept, it's a little bit difficult to get your head around. And it's easy enough in the top box there when there's one car. When there's two cars, it gets a little more complicated. But what about that third one where there's a motorcycle next? The motorcycle's not supposed to be there, I get that, right? But are you supposed to just run into the motorcycle because he's not supposed to be there? And he can go... I don't know. So it's all about those little subtle glances that you give everybody. It's like, right, did you see that? Yeah, you all saw it, but is a computer going to be able to see that? And eventually a computer will be able to pick up the right signals. But it's too much to codify all of that in rules. That's where machine learning algorithm comes in. Convolutional neural networks, to recognize everything. Recognize the motorcycle next to you, recognize the car, recognize the faces, all right? And recursive learning algorithms to say what's the next best action. Okay, so machine learning is all around us. Now, that's a very forward-thinking technology. I want to talk about another case that I've been that I thought about very recently. I was able to participate in the 20-kilometer run through Brussels a couple of weeks ago. And I had a pretty good time. I'm not afraid to boast a little bit about that. But afterwards, all of my SAS teammates, I wanted to see them as they were coming in. And I was thinking, God, wouldn't it be great if I had an app to identify all of them coming in? And because I was dog-tired, it was a hot day, and I wanted to see, yeah, if I could spot. I didn't spot a single one of them. But I thought about how it would work, and one thing, we were all wearing these green shirts. Right? So that makes the problem a lot more simplified. And that's another important thing about any kind of machine learning. It never operates in a vacuum. You need to be able to embed it in the business logic that makes it work. And in this case, if green shirt, then do facial recognition. Now, another interesting thing about that run is, it was a very hot day. I wanted to take my backpack with me to have some food and some water with me. I wasn't able to carry my backpack with me. Anybody guess why? What's that? Boston? Yeah, the terrorist threat, absolutely. That's what it was. And so I was thinking, oh yeah, my app could actually be pretty good for spotting potential terrorists as well. But that business rule that I put up at the front, unfortunately, or perhaps fortunately, if you like green shirts, the terrorists aren't going to just put on green shirts so that we can easily identify them, right? So it's a different context. It's going to require a different set of rules to be put into effect, to put into an operational context efficiently. Third case, and this is getting more into what SAS is actually working with. These are cases that we're actually working on. Just about everybody has something that looks like this in their back pocket. And deep within one of those are a lot of these. The semiconductor industry cannot keep up with the demand for their chips. So anytime they can preemptively predict that something is going wrong in the production process, that means beaucoup money for them. It means a lot of cash, and they really want to focus on that. Now, they're collecting all kinds of sensor data throughout the whole production process, but as some of you may have heard earlier, they're also collecting a lot of photos, microscopic photos in the production line to identify different types of emerging defects, like water defects. And it's important for them to be able to classify those. This is done with image recognition technologies and with convolutional neural networks to classify. Now, this is a great image recognition challenge because a lot of the noise is taken out of it. It's one camera, or maybe multiple cameras, but they're always in the same place in the production line. It's always the same angle, it's always the same lighting. So if there's any deviations, it's easier to pick those out. Let's talk about another one where it's not so easy. And again, this is all about having the right algorithms running in the right context. They never run in a vacuum. We talk about an insurance case. This was discussed in the technology plenary this morning for those of you who are early risers and came to get your free breakfast and was able to hear a great presentation about all different types of analytics impacting the insurance industry. And this one is about having an app on your phone where if you're unfortunate enough to get into a car accident, take a picture of that. That picture can be passed along to an algorithm to determine quickly, is this car a write-off, or is this car need to be subjected to a time and resource-intensive claims process? Okay, that means a lot in customer service. It means a lot in efficiency within the insurance organization. So this is really innovative technology that's really helping to revolutionize the auto insurance industry. But let's take that to a more provocative level. Okay, we can look at this question: will a robot approve my loan? As well, I'm just concerned. Am I going to get the loan or not? If I'm a single mother. I'm not a single mother. But if I were a single mother, is the computer just going to say no? Computer says no. Okay, we can't resign ourselves to any type of computer says no. Okay. First of all, we have within the organization, it has to be transparent. But second, there's legislation coming, GDPR. I'm sure you've heard already something about it today. If we're not transparent about the way the data is being used and the way that algorithms are being used, we're going to get into trouble. And I think that's rightly so. We have to be cognizant. Each and every person within the organization, and that's not everybody needs to understand the mathematics involved in fitting a neural network, but they have to understand the factors that are being weighted in those algorithms. If we talk about the Tao of risk, and Thomas Davenport, he's done a lot of great writing talking about analytics in organizations, in industry. About 15 years ago, he wrote a great book called Competing on Analytics, where he tried to differentiate between analytics you need to do as a cost of doing business, and I think that's happening. Machine learning is viewed as a commodity. You saw it in the Uber slide, right? But then there's also the analytics where you want to really focus on in order to develop a competitive edge. His latest book, Humans Need Not Apply, he's talking about this concept of augmentation and how we need to be constantly in the center of what these computers are doing for us. And it's a nice division of tasks here. Some of the things like coming up with the lists of key risk factors and quantification of risk metrics. A lot of the numbers crunching. The computers are really good at that, and we don't necessarily need to be spending all our time on that. But on the other side, getting those consensus decisions and having the strong relationships between departments, making sure that the assumptions and everything that is going into the algorithms is very transparent. So there's always going to be a human side to what these machine learning algorithms are doing. Computer says no is never a satisfactory answer, a fully satisfactory answer. We need this algorithmic transparency to ensure proper execution and ethical outcomes. This slide demonstrates the evolution of SAS technology over the years. Back in the 80s, where you had multi-vendor architecture, that no matter where your SAS was running, was it on a mainframe or on a Unix or on a Windows environment, that you had the assurance that it was the same SAS. In the 90s, it went out to purpose-built solutions, things like Enterprise Miner, so that data scientists, they weren't called data scientists then, but the analysts could get to work quicker and more efficiently and in a more transparent way throughout the organization. In the year 2000, things branched out into pushing the analytics where the data sits, pushing it in database, on the grid, and memory. Then we had the streaming technologies coming in, where you could actually, before the data is thrown down to a data storage, you could analyze, you could intelligently filter that data. So the idea is, if we want to enable innovation, we want to enable augmentation, and we want to enable transparency across the whole analytics endeavor within the organization, how does the next generation analytics platform need to do that? And who can guess what I'm going to talk about now? Probably a few of you can guess that this is where the four cornerstones of the VIA platform really come in. That it's adaptive, that those algorithms can get the feedback loops they need in order to learn. And when they eventually outlive their purpose, they can be retired and new models can be brought in. That it can be adaptive to emerging business trends. It also needs to be open. And what we mean by open is it needs to be open to different technologies. It also needs to be open to all the different data streams coming in. Okay? It needs to be unified. That means your data prep, your analytics, and we as data scientists often forget or don't emphasize as much that last step, that last crucial step of visualizing it, of making it really transparent, really digestible for the rest of the organization. This is important to create an analytics culture. People don't want to feel like there's a black box with statistical nonsense going on in there that they don't understand. They want to make sure that they have really good transparency into what's going on with that. And finally, it needs to be powerful. It needs to move at the speed of business. It means that it needs to run where the business is happening. That if you develop an algorithm, you develop business rules, or combinations of those, that it runs consistently across all those different channels. I have a drill down on each one of these. Those are the key concepts behind making it adaptive. You have some obstacles. You always have some opportunities. Same for making it open. You want to make sure that we get out of those business silos. We want to make sure that our marketing offers are risk-informed. By having a platform across those departments, we can make sure that that happens. Collaboration, making sure that what one department is innovating, that other departments can also make good use of that. want to make it unified, as I said. We don't want to have this fragmented approach. And that's why we want to bring open source into SAS and make it available within SAS. And making it powerful, scaling to today's advanced machine learning use cases. Because as I said at the beginning, machine learning is becoming a business commodity, right? So if you're not thinking about how your business can use it as a cost of doing business or can compete on machine learning, your competitors definitely are. You may have seen this slide in a couple of decks. I think it's an important slide because this analytics journey needs to be transparent and useful for all different types of end users. It needs to be useful for the IT resources that need to manage it. It needs to be manageable for them. Business analysts need to be able to throw data together quickly to quickly prototype. Domain experts need to have a good view on what is happening with these algorithms and in these different reports. An application developer needs to be able to get some of that analytic goodness quickly in the way that they're used to. We talked about APIs a number of presentations today, being able to access SAS analytics via APIs. The data scientist doesn't want to be bounded by technology. They want to be free to innovate. And they want to be able to take some of the latest and greatest that open source provides, that SAS provides, combine it in those killer analytic pipelines. The executives need to make sure that what's happening is consistent with the strategies and cultures of the organization and needs to make sure that everything is performing. So having that upper level and making sure that it's compliant with external legislation and with the corporate ethos. And finally, everybody's a partner. Everybody's partnering with everybody. That's how innovation works. And you need to be able to make when you want to, make your results, make your algorithms accessible to partners. Going back to Thomas Davenport, there's a lot of interesting terms on here. I don't, unfortunately, have time to get into all of those now. But that last term of augmentation by humans, he talks a lot in this book about the different industrial revolutions that we've gone through. And he likes to equate what's going on with machine learning and artificial intelligence as an equivalent industrial revolution. And that what was interesting about each one of those industrial revolutions is everyone thought, oh, we're going to lose too many jobs. That's where augmentation comes in. We need to be aware of what the algorithms are doing so that we can augment them, so that we can add value to them and we can continue to innovate together with the algorithms, with machine learning, and with artificial intelligence. And I think that's a good takeaway from that book if you get a chance to read it. Who's familiar with what this is? It's from 2001, A Space Odyssey. That's HAL, right? The malevolent supercomputer, right? We need augmentation to make sure that HAL doesn't happen, right? And of course, I feel that one of the best ways to do that is to have an inclusive, transparent analytics platform within your organization. And that's VIA, of course. So that's about what I wanted to round off with. What was that pattern recognition we had at the beginning? Can we get that going again? Johnny, you're a boy, make a big noise, playing on the streets, gonna make yourself big someday. You got mud on your face, you big disgrace, kicking your can all over the place, singing, we will rock you. SAS will rock you. Thank you very much.